Down Ramon's House of Math. Let's fool around with some fractions. How about algebraic fractions? All right, so we know this is x squared. So there's my drawing of x squared. And then okay, what I have there is 1,000. So you can scale them. This is stylized, what I'm drawing there, because you can see that they should be a lot longer, but this is what I'm doing here. So what we have there is 1,000 over 100, or I could say 10 to the third over 10 to the second. But I'm not going to give some rules about what to do about exponents and so on. How about if I see that, can you see that I have, this is 10 by 10. So this is a common factor of 10. So what I'm actually doing is, oh, there you go. So now I can see that if I just look at this, I have 100 over 10, just looking at the edge. So let's see here. I can say that's 100 over 10. All right, now I could have solved the whole problem by just doing this. And now what I have is 10 over 1. All I did was turn this sideways. Instead of using one of these, I stretched it out and used one of these. So clearly what we did is find the ones. Let's take a look at this. So if I look at this as base 10, well, I can just as easily look at it as base x. But let's finish this. Here, I still have, can I see that 100 over, is the same thing as 10 over 1, there it is. And I can also say, let's see here, 10 to the third over 10 squared is going to be 10. Something about subtracting. Okay, so let's see here. Let's take a little further look at this. Let's play a game called Find the Ones. See, because what this is 10 times 10 times 10. And what this is 10 times 10. Well, let's see here. If I play a game of Find the Ones, there's that. There's that. Oh, and now it's just 10. And what that basically says is, how many hundreds in 1,000? 10. We can count them. We can count them this way. And that's all we're doing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Or we can count them this way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's all it is. Let's play in base x. So now it should be really easy to see. Let's see here. X to the third over x squared. Well, let's just play a game of find the ones here. Because isn't x to the third just x times x times x? And down here, I'm not going to put all the parentheses in. And down here, I have x times x is the same thing as x squared. Well, I'm just going to play find the ones again. And so, yeah, so all I have there is x basically over 1, because that's x times 1. But I mean, you know, I could do x over 1. Let's see, 1x over 1 to the first. But do I need all of, no, it's just x. It's just x. And we can see, there it is. And all I did was say, okay, now instead of this being 1,000, this is x to the third. So it could be any. It could be 10 to the third to any of them. And over here, here's my x squared. All right, so we just change the name of the pieces for the little ones. And we can take a look at it and just see, Now, here's something. How is it that some of you made it all the way through school And no one ever told you that the name of this thing right here was the vinculum. And that if you see it like this, that's a solidus. How is it possible that you made it through 10, I don't know, 12, maybe 16 years of school? And nobody told you that was a vinculum and this is a solidus. Anyway, any little child can learn this. We're just fooling around in algebra. Crouton Ramon's houseofmath.com for more. Yeah, it's fractions. It's easy. It's fun.